So how do we find this angle phi? So we know that the general form of a conic is going to be ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Oops. And what we found was that this xy is basically the rotation of the axes. And what we want to get rid of is basically this thing, because this is giving us a hard trouble. So if this thing was gone, then I can easily identify what conic this is going to be, given some angle phi. Now we want to figure out what this angle phi is. So we want to first get rid of this bxy. So the first thing that we're going to do is that we're going to substitute the equations that we just found in the other video. That x equals x prime cosine phi minus y prime sine phi. And we also know that y is equal to x prime sine phi plus y prime cosine phi. And what we're going to do is something that's super duper tedious, which is basically plugging everything in. So we know what x is and we know what y is, and we're going to plug it in here. And you can already imagine how ridiculous this is going to be. So you're going to have we know what x is. X is going to be x prime cosine phi minus y prime sine phi squared plus b, because the b term is still there, it's still not gone, x times y. So that's going to be x prime cosine phi minus y prime sine phi times x prime sine phi or phi or whatever you want to call it plus y prime cosine phi plus all this other junk, okay, equals 0. So we are going to do a lot of FOILing. It's going to be really, really crazy. And now what we really want to do is we want to solve this. And so what we're going to do, we're going to expand, solve, do a lot of things. And what we end up getting is this. We end up getting that a prime x squared plus b prime xy plus c prime y squared plus d prime x plus e prime y plus f is equal to 0, which it looks very similar to this, but you're probably wondering, what exactly is this a prime, y prime, f prime, all this other stuff? Well, I wrote it down here for you. A prime, b prime, c prime, d prime, e prime, and f prime is equal to all of this. And no, you don't have to memorize these formulas, because this is only going to be useful because remember that we want to get rid of the xy term, because that's the thing that's giving us issues. So we want to get rid of this thing, this new b term, this b prime xy, because once this is gone, we have something that we can try to rotate. So we are going to take this b term. We want this b prime to equal 0. So that's what we're going to do. So we have 0 is equal to 2c minus a sine phi cosine phi plus b cosine squared phi minus sine squared phi. And we're just going to solve all of this thing. So some of the things that you notice is that you can use a trig identity here. This thing is just going to be equal to, so when you have 2 sine phi cosine phi, that's just going to be c minus a sine of 2 phi. And then b, this thing is another identity. This is just going to be cosine 2 phi. Okay, I'm going to subtract this over to kind of just make it a little cleaner. So minus c minus a sine 2 phi. So this is going to go away. So I can distribute this negative, and we're going to have a, minus c sine 2 phi is equal to b cosine 2 phi. I can divide the sine over, divide, and what I get is a minus c is equal to b. We know that cosine over sine is just going to be cotangent 2 phi. I'm going to divide by this b now, and what we end up getting is that cotangent of 2 phi is equal to a minus c over b. So if I want to choose an angle that will make the b term go away, then this formula is going to be useful. So we know that in order for me to rotate the axes, what I require is the following. So I need to use the fact that x equals x prime cosine phi minus y prime sine phi, and y is equal to x prime sine phi minus y prime cosine phi. That should be a plus. So these are the formulas that I'm going to use with phi satisfying cotangent of 2 phi equals a minus c over b. So this is basically the rules that I want to use. So I'm going to substitute my x and my y with this one to convert it to x prime y prime, and then I'm going to select phi such that this is satisfied also. And this will eliminate the b term. And if it doesn't eliminate it, if the xy term is still there, then probably we did something wrong. So in the next video, I'm going to do a problem, and you'll see how tedious it can be.